Hi, welcome to Number Club. This is Year 1 Pure, Chapter 3, Lesson 4, and today we're looking at linear inequalities. So let's get cracking. So the first question says, find the set of values for which 2 lots of x minus 3 has got to be greater than 2. Now you should recognize this type of thing from much lower down the school. You've got two options. You can either expand out the 2 or you can divide through by 2. It's entirely up to you, but most people would probably just expand it out. So we get 2x minus 6 is greater than 2. So 2x is going to be greater than 8. X has got to be greater than 4. Okay, when x is greater than 4, we should get something that's greater than 2 out of this. If we substitute it in 4, we get 4 take away 3, which is 1 times by 2, which is 2. So when x is exactly 4, we get exactly the same. Anything bigger than that, we're going to get this left-hand side being bigger than this right-hand side. Now, you should know that this can be expressed on a number line. So I'm going to put a number line. Generally, negative 2, negative 1, 0, 1, 2, 3, 4, 5. Generally, you only really need your critical values, but you should know how to express that on a number line. Now, there are a few tricks. One thing is that an empty bubble is for greater than or less than. So this will be greater than. The arrow will go the same way as your inequality symbol. So the arrow here will go the same way as your inequality symbol. So you've got that one. We've got less than, so strictly less than. We've got greater than or equal to is shaded in. Okay, greater than or equal to, and less than or equal to is also shaded in. Okay, one way that I remember these, and it's a really weird way to remember these, which is if this is coloured in, I always think of it as being bold, and if it's bold, we should really underline it. Okay, bold and underlined, and you've got the empty ones. Okay, find the set of values for which this horrible looking thing is less than this horrible looking thing. Now, this is mean looking because it looks like it's all quadratic here. So the first thing we're going to do is we're going to expand it out. So we'll get x squared plus 6x plus 9. You might take longer over that. It's fine. X squared plus 5x plus 14. Okay, we are going to subtract x squared from each side. So we'll end up with 6x plus 9 has got to be less than or equal to 5x plus 14. We're going to subtract 5x from each side, and that's going to be x plus 9. It's going to be less than or equal to 14. And we're going to subtract 9 from each side, and we're going to end up with x being less than or equal to 5. Okay, so x has got to be less than or equal to 5, which would be like this. Okay, you don't really need to extend that on for absolutely ages. The arrow kind of implies it'll go past these numbers as well. Now this is the part that's a bit more A-level-y. These things really, this would be a bit difficult for GCSE, but this would certainly be GCSE level. This isn't much harder, but this is definitely A-level. It says find the set of values for which the first equation works, the first inequality works, and the second inequality works. Always double check that they're the same. Okay, we want them to work for both. So let's try numbers. So say that we had 1. Well, 1 would work for this equation, but not inequality, but not for the first inequality. 2 would work for the second inequality, but not for the first inequality. 3 would work for the second one and not for the first one. 4 would work for the second inequality, but not for the first one. Be really careful with that because this is x is strictly greater than 4. Here, 5 works. Okay, 4 doesn't work, but anywhere in between does work. Okay, so we don't want that bit there. Okay, so what we want is for x to be strictly greater than 4, but also less than or equal to 5. Okay, x can be 4.1, 4.2, 4.01, 4.02. Okay, but it can't be 4 because that would invalidate the first inequality. So that is the set of values. Now this will typically be fine, but at this point it'd be a good idea for you to know about how to write set notation. Now set notation, this is set notation. There is a set of values with variables labelled x such that x is between 4 or 5 and can be equal to 5. That's how set notation is written. Okay, it is this thing. You should be thinking of it as there is a set of values with variables labelled x such that, okay, and we've got this thing. In general, you're going to basically have whatever your inequality is with a dot dot and an x and a pair of squiggly brackets. Okay, that's set notation, and it's well worth knowing about that early because you could be asked about it at any point. So let's move on. So find the set of values for which negative 2x is greater than 4. Now this looks like an easy one, but you should remember from GCSE, if we're going to divide through by negative 2, there's something very specific that we have to do, which is that we have to flip the inequality. Okay, when we divide 4 by negative 2, we get negative 2, by the way. Okay, we have to flip the inequality. X has got to be less than negative 2. Try it. Try, say, x equals negative 3. Would it be true that negative 2, lots of negative 3 is greater than 4? Yeah, 6 is greater than 4. So it works. We've got the correct side of it. The critical value is always going to be negative 2, but we just want to make sure that we've got the correct side. And so I'm happy with it because I chose something that worked for this inequality at the end and it worked for the inequality at the start. Okay, find the set of values for which 6 is less than x plus 1. Well, 5 will be less than x. People don't tend to like that. I certainly don't tend to like that. So I tend to prefer to mirror image. If 5 is less than x, x is greater than 5. Okay, we can again try it if you want to. Try out a number that does work for this, which is 6. Does it work for this? It does, and so we definitely did the right way around. So we had the set of values. We're trying to find the set of values for which the first inequality works or the next inequality works. Now in the previous one, we needed values where both of these lines worked, where both of these inequalities worked. So it had to be this sort of area, didn't it? Whereas in this case, we've got x being less than negative 2. So we're going to go from negative 2, negative 1, 0, 1, 2, 3, 4, 5. I'll show you in a second that you don't really need those. X has got to be either less than negative 2 or greater than 5. It's or, so you only need to work once, okay? You don't need to work both times. So here, this stuff is obviously no good at all. For example, 0 doesn't work for either. But say 6 does work for this, but doesn't work for this. But it's or, it's only got to work once. So we've got x has got to be less than negative 2 or x has got to be greater than 5. Now to write that in set notation is a bit more difficult than the previous one because this is two separate sets. Okay, two separate sets of values. Can you think of a number that's less than negative 2 and greater than 5? I can't. So we need two separate set notations. The separate set notation is going to look like that. You've got a set of values with variables labelled x such that x is less than negative 2 or, now or should really be one of these things, the set notation kind of U shape. Okay, we've got the N shape, which is for and, like fish and chips. Fish and chips. Okay, you get both. And we've got or, which is greater than a set of values labeled x such that x is greater than 5. So that would be a perfect answer in set notation. But for the most part, the 90% of questions, this will be fine. Okay, if it's asked for strict set notation, that's what you need to know how to give. All right, and also you might see answers in mark schemes that look a bit like that. I wouldn't want you to be puzzled. All right, moving on. Find the set of values for which this stuff happens. Now, in a previous question, I think the very first one, I expanded it out. I'll show you what happens if you do a division method. So division method would be to divide by 3. Okay, 2x has got to be greater than 10, and then x has got to be greater than 5. Easy. Set of values, expansion here, x squared plus 3x plus 2 has got to be less than x squared plus 2x plus 10. I'm going to take x squared plus 2x off each side, and so I'll end up with x plus 2 has got to be less than 10, x has got to be less than 8. Okay, we want an or value here again. This is an or, So my critical values are 5 and 8. I want values of x that are greater than 5, okay? And I want values of x that are less than 8. All right, now we know 6 will work for both. If it was and, 6 would be critical, 7 would be critical, okay? 7.5 would be critical. But in an or question, it only has to work once. So, in actual fact, x can be any number. X could be 9. It doesn't work for the second inequality, but it does work for the first. X could be 4. It doesn't work for the first inequality, but it does work with the second. And so x can be any number. Sometimes you might write that as x exists within the real numbers. Okay. X can be anything. All right, thanks very much for watching. Visit numberclub.org to find more videos and tasks. If you get a chance, subscribe to the channel. Thanks very much for watching. Cheers. Bye.